key parameter number to C25 AA. Today we will discuss topic about the nature of hypothesis testing. Hypothesis is a premise or claim that we want to test, or hypothesis is a statement that something is true. For example, the mean of weight on all bags of pretzel package different from the advertised weight of 454 grams. Another example is the mean of students in class is more than 20 years old. The next topic is hypothesis test. Null hypothesis is a claim or statement about a population parameter that is assumed to be true until it is declared false. Alternative hypothesis is a claim about a population parameter that will be true if the null hypothesis is false. Next topic is choosing the hypothesis. If we know hypothesis is null, we will use this formula. Next is alternative hypothesis. If the population mean is different from a specific value, it is mean to tell test, and we will use this formula. Next is if a population mean is less than a specific value, it is mean less tell test, and we will use this formula. If a population mean is greater than a specific value, it is mean right the test, and we will use this formula. Okay, after we have chosen the null and alternative hypothesis, we must decide whether to reject the null hypothesis in favor of the alternative hypothesis. Any decision we make based on a hypothesis test may be incorrect because we have to use partial information obtained from a sample to draw conclusions about the entire population. There are two types of error. Type 1 error is rejecting the null hypothesis when it is in the fact of true. Type 2 of error is not rejecting the null hypothesis when it is in the fact of false. This is type 1 and type 2 error table. Next is relationship between type 1 and type 2 error probability. For a fit sample size, the smaller we specify the significance level, the larger will be the probability of not rejecting a false null hypothesis.
Hello everyone, my name is Kai Ting. With the critical value approach to hypothesis testing, we choose a cut-off point based on the significant level of the hypothesis test. The criterion of deciding whether to reject the null hypothesis involves a comparison of the value of the test statistic to the cutoff points. We totally have three regions, which is rejection region, non-rejection region, and the critical values. This is the example of showing three of the region. This is the example of the sign in alternative hypothesis when it is not equal, so the rejection region is at the both sides. When the sign in alternative hypothesis is smaller than, the rejection region is at the left tail. If the sign in alternative hypothesis is bigger than, then the rejection region is at the right tail. This is the formula to find the test statistic for a one-mean Z test.
I'm Lee Xiu-Niang. I'm going to explain about p-value.
What is p-value? P-value is used in hypothesis testing to help you support or reject the null hypothesis. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. And letter P is used to denote p-value. With the p-value approach to hypothesis testing, we first evaluate how likely observation of the value obtained for the test statistic would be if null hypothesis is true. The criterion for deciding whether to reject the null hypothesis involves a comparison of that likelihood with the specified significance level of the hypothesis test. Decision criterion for a hypothesis test using p-value. If the p-value is less than or equal to specified significance level, reject the null hypothesis. Otherwise, do not reject the null hypothesis. Let's look about three types of tests. First, two-tailed test. The p-value is the probability of observing a value of the test statistic Z that is at least as large in magnitude as the value actually observed, which is the area under standard normal curve that lies outside the interval from negative Z to Z. Next, left-tailed test. The p-value is the probability of observing a value of the test statistic Z that is as smaller as or smaller than the value actually observed, which is the area under the standard normal curve that lies to left of Z. Last, right-tailed test. The p-value is the probability of observing a value of the test statistic Z that is as large as or larger than the value actually observed, which is the area under the standard normal curve that lies to right of Z. Next, p-value approach. Purpose: to perform a hypothesis test for a population mean. Assumptions: simple random sample, normal population, standard deviation is known. Step 1. State null and alternative hypothesis as given. 2. Decide on significance level. 3. Compute Z value using given formula. 4. Determine p-value. 5. Decide whether reject null hypothesis. 6. Interpret result. Hypothesis test without significance level. Many researchers do not explicitly refer to significance level or critical values. Instead, they simply obtain the p-value and use it to assess the strength of evidence against the null hypothesis. The strength of evidence are as the table given.
Hi everyone. My name is Muhammad Faristakullah bin Hainuddin. This is assignment for TL. Our title is hypothesis test for one population mean when standard deviation is unknown, small sample. Introduction. We can perform a hypothesis test for a population mean when the population standard deviation is unknown by proceeding in essentially the same way as when it's unknown. The only difference is that we invoke a t-distribution. This is a variable for this cost. They have 3 tests of hypothesis about you. One mean t-test. Assume that simple random sample, normal population or last sample, standard deviation unknown. This is step 1, step 2, and step 3. This is step 4 for p-value approach, step 4 for p-value approach, step 5 and step 6 for value approach and p-value approach. So let's see some example. This is solution from the example. Step 4 and step 5 for critical value approach. Step 5. Step 5 for value approach. This is graph for step 5. Okay, let me show you some more examples. Example number 2. Is a solution. Step 1, step 2, and step 3. Step 4, critical value approach, and step 5, critical value approach. This is graph for step 5. For critical value approach. Step 4 value approach and step 5 value approach. This is graph for value approach.